Well, good day, everyone. We're just going to wait another minute or so here before we get started. And in that way, we'll be able to accommodate those who are maybe having a little challenge getting on or new to the system or are just maybe just slightly late. So if you bear with us for just another 60 seconds or so, we'll get started. And Tony, maybe we can just have a conversation, you and I, just real briefly, for those who are on the system already. I was in traffic just last weekend, and I was right next to a brand new Duramax, and I noticed I wound down the window because it was so quiet, but it was a stop-start system on this Duramax.
Yeah, I heard about that.
Yeah, and I thought to myself, oh, every additional component that's added to these vehicles and more opportunities. I know it makes systems far more complicated, but boy, are there new opportunities for all of us out there in the marketplace, for fixing the vehicle.
I'm like, oh, what, yeah. Yeah,
Yeah,
because the minute you turn it off, you drop the pressure. Now you got to raise the pressure back up, but the residual fluid's still there, so it shouldn't take long.
yes,
But given the fact that it's a diesel, the thing is these newer diesels have lower compression.
yeah,
Their compression ratio is smaller, so not as much as a strain on the starter. But yeah, I could see that being a headache. But it's all
yeah,
emissions driven,
yeah,
so
yeah. And I think to myself,
I'm
that
like,
person there probably paid a good at least 75 grand or more for the vehicle. Are they
oh yeah.
really interested in a few drops more of or less of fuel? But anyway,
But
it's the powers that be and emissions that drives all the new components on there.
yeah, my
Anyway,
mother
I
has a
think
Buick. My mother has a Buick Envision with the stop start, and oh my God, I hate it. Every time I drive her car, take it somewhere for her,
yeah,
it's
yeah. The
annoying.
first time you get in it, it's like, oh my goodness, what's happened to the vehicle? But I've learned
Yeah,
that
I
when
don't
you
like it.
drive it and you come to a stop, if you don't actually put the brake on and keep it really tight on there, you just ease off a little bit, it'll keep on running. And then
Yes.
you can really stop at it. So you can fool it a bit. Anyhow, we'll get started. So good day, everyone. My name is David Failing. I'm with Lucas Diesel Systems. And on behalf of Lucas, I'd like to welcome everyone to this is the fourth webinar of 2024. These are monthly webinars for the foreseeable future, as far as we can see. So we're very proud to be able to present Tony and his wonderful knowledge and expertise on all of these different challenges that we all have in the marketplace here on repairing vehicles. A couple of housekeeping items. First of all, everyone's muted and you're muted as far as the video is concerned as well. I would suggest that if you have some questions, you place them in the Q&A section that's either at the top of your screen or the top of your bottom of your screen. If you move your mouse around, you'll find the Q&A section. Put the questions in there, and then we'll try and answer as many as possible at the end of the webinar. In addition to that, everyone who's participating live on the webinar will receive a certificate of participation on this webinar. So look out for that a little bit later on. We are recording this webinar. So basically at the end of the webinar in a day or so, we'll have that posted on our YouTube channel. And I know that Tony also posts that on his webpage. So for those of you who missed something or like to review or refresh, then you'll be able to see that on both devices. Let me see. We'd like to before we get started. Let me see. Sorry, I've got a PowerPoint here. We'll go on to the next one. I'd like to do a little bit of promotion here of Lucas Diesel Systems. Here we have a promotion for remanufactured C15 injectors. We're offering, if you can see all those different part numbers on there, 5% off of your order. In addition to that, we offer a 2-year unlimited warranty. And as an FYI, each one of these injectors has got a QR code so you can trace, its build and test procedure as well as the quality control of that specific injector. In addition to that, we also have a variety of turbochargers, and here we're offering a 10% off of Series 60 turbochargers. Here we also have a 12-month warranty, and it's coreless. In other words, you don't have to return the core. So once you get the core back from your customer, then you're free to do whatever you need to do with it, including, remanning it and so forth. In addition to that, we're also offering a 10% discount on a variety of components for remanufacturing of common rail injectors. In addition to that, the minimum order is $1,500, but in addition to that, later on, you can also receive 15% off your next monthly order. So in other words, you purchase something from us and get 10% this month, and then next month you can get another 15% off of your additional order. So consider us, please, when you're doing any type of work, fuel injection work out there or turbocharger work. We have a variety of different components available for you. And here are a couple of contacts if you need to get hold of us for either ordering components, if you have any questions or anything like that. Either Erica or myself can help you out. So without further ado, I'd like to introduce Tony Salas. Most of you know Tony by now. Tony has been in this industry for, I don't know, a good 40 plus years, right, Tony?
You had to say that, didn't you?
Yeah.
Yeah.
So Tony is an instructor on a variety of different subjects on automotive diesel, as well as having his own not fuel shop, but repair facility. So Tony gets to see a lot of the various different problems that are associated with automotive diesel and can bring us his expertise here. So without further ado, the seminar today is called CAN Network Review and Analysis. No communication. And I believe we do have communication with Tony. So Tony, if you'd like to just take it away, I will stop sharing my screen and you can put yours up there. Thank you, Tony.
Right. Thank you, Mr. David, for the intros. Welcome everybody to the Lucas-sponsored webinar. Once again, it's already the end of April, and we're going to have a May one too, don't worry, but we have April. The subject is actually, yes, networks, vehicle networks, CAN, and more. So welcome. Please feel free to hit the chat button and ask any questions. I'll try to answer them throughout the presentation. If not, we'll have a Q&A towards the end here. So when we're talking about CAN networks or diagnostics, I mean, what's driving this? Why am I teaching this? Well, if you saw the roundtable earlier this week, you probably got a sneak peek about it. But I got to tell you, though, the obvious. I have, but also had to work on the eating lunch. I'll pop somebody's presentation or watch a presentation. I always watch other stuff to get ideas or to see what's going on and what people are talking about. So Tony tries to stay, up to date on what's going on, right? So with that said, I don't even know how to tell you this. I'm watching a complete diagnostic. This guy's going through a scope, going through everything, trying to figure it out. And turns out at the end, it was a connector off. I won't say what and where, but it was a connector that was off. And I'm like, really? You did this whole presentation and it was just a disconnected connector right there. And watched another one. And then I saw an article of a guy, and this guy even published the article. Again, I'm not trying to put people down, but I want to make a point here. That's not my mission. No, my mission is that all these presentations that I've seen, 3 of them this week, 3, 1, 2, 3, all we're talking about how they do this test, how they hook up the scope and this and that, and they're doing a diagnostic on a vehicle, trying to figure out what's going on with it, right? And all 3 scenarios were all connectors. And I can't tell you how that frustrates me because, I would have been embarrassed to actually put a video up that way because I would have said, oops, I screwed up. But they don't even say that. because this is where that diagnostic routine, and it's kind of getting on my nerves because, and I believe me, I'm not trying to fuss at you, but would you, this is why, again, a diagnostic strategy is very important, because isn't there such a thing as a visual, right? And in this case, we want to visually check stuff to see what's going on. So, we've reviewed in the past networks, and we have, and there's a lot of presentations out there talking about networks, in other words, CAN and so on. But why do I need to know this? Well, we're going to try to clear that up here in a minute, but it's all part of your today's diagnostics, and that a lot of it has changed. So we have to understand issues or malfunctions that you as a technician can see in your shops. But again, basics, please. Okay. And I've been preaching and preaching, but I'm trying to let go of that, but you don't let me, because it still happens and it still occurs. So therefore, know how it works. Okay. Let's get it one thing clear. And that's what you're here for. But on the other hand, let's be fair. If you're expecting to learn everything about networks in an hour, hour and a half that we might be here, no. You need to do some update training. You need to take a course, whatever it is. But in this case, you need to learn a little bit more. Now, let's take a look at a turbocharger. Here's my slide from a Duramax, okay? And when I look at the slide on a Duramax, I can see here that here is the ECM in the middle, and you can see all the inputs that play a role in turbocharger operation. So there's your turbocharger over here, and we're looking at this, right? So in this case, we have turbocharged vane position control and then the sensor, right? So there's two in and outs, right? Obviously, there's more wires, but there's power and ground. But we're just trying to illustrate there that it's a series of executable voltages and current, and also a reading of that sensor, which is a 3-wire sensor, which tells us what's going on. So again, there's more wires here. But what I'm trying to say is, you look at this old technology, and yes, it is old technology, for the simple fact that how is the ECM now communicating with the turbo? So I'm going to change here. I'm going to shift, or I'm going to take a risk here. And what I'm going to do is I'm going to go to the service manual. Hopefully this will work. I practiced, so let's see if it works. But anyways, what I wanted to show here, I got a U code here. Okay, so obviously you're going to have U codes. Now there are situations where I will be trying to diagnose a problem, and I said, you know what? I'm going to look up the code that's related to that and see if I can fix it. So those of you that are novice or not competent in this, please note there's a theory of operation. But when we look now at a Ram Cummins for quite a while, that whole set turbo, we read here that the variable geometry turbocharger is electronically controlled by the electronic turbo actuator. Everybody knows about the actuator. At least I hope you do. Now, the actuator is a smart device. It communicates information from the PCM over the private data link. The electronic turbo actuator performs its own internal diagnostics and reports failures back to the PCM, and the PCM then decodes the error message and converts it into a fault code. So in other words, RAM with their turbo compared to Duramax on those older LML and earlier models, the actuator is actually a smart little module. So therefore it talks over the CAN network, or like they like to call it, a private data network. So therefore, what people often get frustrated is like, why do I have to deal with networks? For the simple fact that things like a turbocharger is actually talking on a turbo. So instead of having all these multiple wires, how many wires is standard communication for CAN, for example? It is 2 wires, right? CAN high and CAN low. So what is the main reason behind this of using such a module is the fact that it saves on wiring. I mean, think about it. How many wires? 2 to the solenoid on a standard turbo, the Garrett style turbocharger. Then you got 3 for the sensor. So that's 5 wires in total. While here, we just need power, ground, and CAN communication. That's it, right? Okay, so we're saving on a wire. But the point is, there's smarts behind it. It can make decisions, and it can actually do its own self-diagnostics. So what we're trying to tell you is that as much as we talk about networks, let's also look at how the manufacturers want you to diagnose this. So in this case, they're giving you possible causes on the diagnostic trouble code. Again, circuit issues, shorted, battery to ground, and so on, electrical principles, if you will, right? And then finally, the last two, it could be the actuator itself, which is common on the RAMs, but also the PCM. But then as we scroll down, and this is what I'm talking about, a procedure. Obviously, there are basics. You're checking connectors and so on. But then you get into make sure that it is an active code, right? So the computer's doing on board. In other words, the network is doing its systems to tell you that, hey, I'm having a communication issue, which will lead you to hey, I need to diagnose this. So I'm always the kind of guy that says, hey, this is new to me. I've never done it before, let's say. This is the first time I deal with this code. I'm going to do a little reading. And in this case, look at the note here, especially the lower one. Actually, both notes. Repair any voltage low DTCs before proceeding with this procedure. The actuator data link is a bus circuit which the PCM uses to communicate with the depth quality sensor, the actuator for the turbo, there it is, the depth dosing control unit, the NOx sensor 1 and 2, plus the particulate matter sensor. The turbo actuator and the NOx sensor are located in their own network in the engine harness. The depth quality sensor, the dosing control unit, NOx sensor 1, 2, and particulate matter sensor, if equipped, are located in separate network in the vehicle harness. So we're getting some good information here, to tell us, hey, you got to watch out. But obviously, you're going to see me talk about the wiring diagram. So then it wants you to look at, are there any lost communication DTCs present, both the turbo actuator and the NOx sensor, right? And then number 3 is my favorite. Number 3 says check power supply to turbo actuator for an open, right? You're checking to see, hey, this puppy's not communicating. Is it getting power? And that's probably a very important point to keep in mind when we're dealing with network issues, because if you have lost communication, immediately you don't want to be thinking, oh, there's a wiring problem, there's a connector problem. Well, it could be a power problem too. What if somebody put an aftermarket device, like let's say power steps or a radio, whatever, and they actually blow a fuse and turns out that caused the issue? So it's important to check the fuses and check to see if you have power. And obviously measuring the power is very important. Like it says right here, you should be above 11 volts, right? Then it wants you to check the actuator data link for open or high resistor. So they want you to disconnect the NOx sensor and disconnect the PCM connector. And what are you going to do? You're going to check to see if you got below 3 ohms. I disagree. It should have no resistance at all, but it may have a little bit. So the moral of the story here, since we're starting out, is that, hey, the U codes can be your friends, and you need to follow those charts to understand what's going on there. So, but we'll come back to the service manual later on. Let me pull back my presentation where I took off. So something as simple as the turbocharger, again, has gone through a lot of different changes. So therefore, we see now the use of networks, right? So it all starts with the diagnostic link connector. We've been preaching in other classes about the diagnostic link connector. If you want a copy of this, send me an email and I'll send it to you. Make it a poster, print it up, put it on your toolbox. Hell, put it on your bathroom door, so you could start learning what each connectors are. Pretty much I'm getting pretty good since I'm talking about these guys rather frequently. Again, 16 and 4 and 5 are grounds, right? And then you got your low speed CAN pin 1, and you got your medium speed. I haven't memorized that one, but we have 6 and 14, which is our high speed CAN. Don't worry, we'll talk about low, medium, and high. But the bottom line is all communication starts here, though, as you will see later on, there are now adapters they're selling, or cable adapters, for actually bypassing, like the star connector bypass you can now use on Ram trucks, right? So we'll talk about that. But again, for us, for general use and general diagnostic, it all comes down to your diagnostic link connector. So we have to understand what we're looking at. Now, please note, we've been using CAN for quite a long time, and CAN's been around for a long time, but it has evolved and changed through the years. So therefore, what used to be single wire communication became 2-wire communication and changing. But we'll mention a few here. But just to give you an idea, I brought up this old slide that I used to use in my older Duramax classes. And no, it's not a Duramax, it's a Cadillac. But for those of you that don't know, we have to get an understanding of how these networks work. So obviously, 6 and 14 is dedicated for powertrain. So this vehicle, like your earlier Silverado Sierra trucks, they also used a body control module. That was the gateway. So in this case, when you were trying to communicate to the ECM, you'll notice that's towards the end, the BCM was the first guy in line. So I guess what I'm trying to say is, in order to talk to the ECM, you had to go through the BCM. So we're seeing gateways heavily now. They were, some trucks used it, some trucks didn't use it, but now we're seeing it very heavily used, a gateway control, and we'll show you that later on. However, though, when you are working on a truck like the early model GMC Sierra, like I said, Silverado, you got to understand that the gateway is sometimes your link in order to get to the rest of the systems. Now, I know you guys don't just diagnose drivability problems. If you're a true shop, you probably deal with air conditioning modules, door lock issues, and so on. But in this case, this one's simple because of the fact that this vehicle has a body control module that actually manages a lot. But were these early vehicles also equipped with other protocols? And the answer is yes. So as we look at pin number 1, which we often call the low speed CAN, that also will talk to other modules. But please note, these early models were actually single wire communication. And you'll notice, again, high speed CAN and low speed CAN. And by the way, GM LAN and CAN are the same thing just about. They'll say not, but yeah, it's just about the same because GM didn't want to use CAN. But anyways, the point is we see that low speed CAN right there for the radio heads up display and other features that the vehicle might have. But then some of these earlier trucks had class 2 communication, which is a single wire communication, but it actually talked to other accessories or modules. So you can say this vehicle right here is trilingual. In other words, it speaks high speed, it speaks low speed CAN, and it also speaks class 2. So this is the early stuff. Well, we've changed it quite a lot through the time. So as I move on to a more modern diagram here, this is courtesy of Mr. Hobbs over at Delphi. And you could see there that, from a GM perspective, you got everything networked nowadays. But the thing is, like Ford, they're really bounced off like crazy with CAN because they're dealing with what I like to call local CAN networks, which are LIN networks. But LINs are often can be single wire communication, right? So therefore, CAN is more two wire. But the bottom line is, I guess the big picture is that as you're dealing with these newer vehicles, then the more newer they are, because we're getting 2019, 2021 trucks now. When you're dealing with an accessory issue, something as frivolous as your door locks, right? Your heating for your rear heated seats or front heated seats or air conditioning seats, your windows and so on are all networked together. And I welcome you to look at what's going on out there on the internet because there's a lot of techs now taking advantage of, let's say, YouTube. And in this case, there's a lot of people, techs that are diagnosing trucks where something as a tail light is a big deal now because you look at the cost of what it costs to fix and what's in the tail light nowadays. It's all networked together. So, you got CAN networks, you got LIN. LIN is local interconnect network, and then there's MOST, which is media oriented system transport. Okay. So obviously I don't have time to go through every which one, but we'll try to get up as much as we can. But when you look at an LML Duramax, you are looking at a fully loaded LML Duramax here. So down here, let me get my marker here. Down here, you're going to find, once again, the diagram here, right? And you're going to notice that this system's a little bit different for the simple fact that there's no clear gateway here. You'll notice it just splits off in different, but we'll stick to the high-speed CAN here, and this is your high-speed CAN, follow this wire, and you're going to see that, yeah, we are seeing the ECM right there. So the ACM is no longer one of the heavy hitters. Who do we see as a heavy hitter here from the accessory side and from the body control side? We see who? Well, I see the BCM right here, and I also see the radio, right? Don't ask me to name all the acronyms. I haven't memorized them yet. But in this case, you'll notice that, you just got an array of sub networks. So therefore, those sub networks, can be this. I'm trying to say that those terms not to confuse you. So therefore, there's your lens right there. Okay. So therefore, what I'm trying to say is that has evolved and more of a reason for us to understand what I'm looking at here. Now, we saw earlier, let's not forget this U code that we just saw for the RAM application, right? So what we're going to see there is the fact that, okay, I'm looking at this. Why do I have to know this? Well, the code's going to tell you, but you're going to find out that who's going to be your best friend to diagnose. I guess what I'm trying to say. I'm going to have a communication problem. Who's going to be my best friend? So I'll tell you the nays or yays about it. But for now, you can see, again, once again, your local networks. That was confusing, wasn't it? Sorry. I'll clear it up here in a minute. I'm trying to, my timing is advanced. But anyways, again, you can see all the connections there. But, this all evolved. When you look at GM on GM trucks, and this is old technology. I mean, we saw this in 2010. So therefore, if you still haven't grasped it, right, it's like, hello. So, many of you probably identify that guy. Okay, that's part of your global scan to a General Motors, right? So therefore, you got to know the bus and know how to tool to use. But we have to know the protocols. What are those protocols? Well, there's CAN, there's Ford SCP, there's Class 2, like I mentioned, there's the Chrysler FCI, there's KID. You got to know those. Obviously, I'm not going to hit you hard on that because it's something you got to research. But in this case, if you're using aftermarket scan tools, you're going to notice all these different protocols that it tries to test. For example, my Matco code reader, it speaks multiple protocols or languages. And what it does is when it's trying to communicate, it switches to try to identify what vehicle it's talking to. It's a pretty smart little unit, and it does read very well. So again, we have to know what they are, and you should know them. So controller area network is a serial bus system suited for network, and it's intelligent, so therefore it works with sensors and actuators. CAN bus will allow more modules to perform fewer tasks. Sensors are hardwired to the closest module, and CAN bus can have multi-master capabilities. So let's come back to this slide here. Oops, there we go. If we look at this slide right here, you're going to notice the one that I've been pushing hard on is the NOx sensors. So the NOx sensors, as you can see, are in the network too. So they're speaking on the CAN network itself, so along with other sensors too. But those are the ones that I'm trying to hit hard and heavy on for the simple fact that, we got to know that it's going to be a problem. I'll put the puzzle together. Sorry, I'm actually trying not to say certain things, but the bottom line is CAN bus can have multi-master capabilities. Several CAN bus nodes can request access to the bus simultaneously. The example I've always given is the vehicle speed sensor. The vehicle speed sensor is actually hardwired to the ECM, but again, does ABS need it? Does the radio need it? Instrument panel cluster need it? And the list goes on and on and on. So therefore, how does it communicate vehicle speed to all the different modules? Well, via the networks, right? So therefore, that's what we need to understand. But before we go too buck crazy, Ford, on the other hand, switching from GM to Ford now. Ford in the early years, like when we talk about the 03, 04, 6 liters, the F-250, F-350, and so on, those spoke SCP communication. So SCP is a data bus they use. So therefore, it is what they refer to as a Class B data bus. It is located on pin 2 and 10 of your diagnostic link connector. So as we look at it here, and this is a popular worksheet that I've used on my diesel master course, is that there's pin number 2 and 10. And again, there's pin 13. We'll talk about 13 in a second. But anyways, pin 2 and 10, this lazy 8 symbol you see across the board everywhere is actually a twisted pair of wires. You're going to find out that most networks that use two-wire communication are twisted pair. Some may have also a ground wire for shielding too as well. Again, electromagnetic interference could be a problem here. So therefore, they're trying to minimize that. But like I've said, there's your PCM right there talking on the SCP bus, right? There's your SCP plus or minus. There's an auxiliary powertrain control module, anti-theft receiver, and your instrument panel cluster right there, all connected on pin 2 and 10. So they're all intercommunicating with each other. So again, SCP data bus, better known as standard communication protocol. But when you got into 05, they got rid of SCP, right? So in this case, the SCP is gone. It went to full CAN. So please make a note of that. So I guess what I'm trying to say is there are some vehicles that are exception to the rule of CAN of that 6 and 14. There's also 2 and 10. So be aware of that. Now, a quick side note. You're going to notice that pin 13 there on the bottom. Let me erase that. Pin 13, for those of you who haven't taken my classes, is FPPS, which is Flash Enabled Programming System. And Flash Enabled Programming is an 18-volt signal that is sent from the scan tool to the ECM or PCM, excuse me, to actually enable it for programming. So one thing you're supposed to check, if you have an issue where the vehicle will not take a program, you're supposed to verify, oops, just off my light. You're supposed to actually what? You're supposed to go ahead and verify the 18 volts being provided there by the scan tool. So therefore, definitely want to do that. So sorry, my light came up off. So lovely suction cup. But anyways, y'all can all see me here still, right? So anyways, there you go. So again, 18 volts at pin number what? 13, right? So therefore, that's what you want to look at. Let me fix this. My apologies. Quality lighting. All righty. Okay, so therefore we see that under those two. But when we look at the high-speed CAN on that same 0304 model truck, what do we see? Well, we see 6 and 14. And on 6 and 14, we actually see what? Well, there's a twisted pair of wires too. We see the symbol there, but you'll notice it goes straight to the PCM, right? So therefore, it's just going straight to the PCM. So as I look right here, there's your CAN bus high, there's your CAN bus low. So as we're looking at this, let's get this clear. 14 is low. CAN bus high is who? Pin number 6. So therefore, that's important to understand because their voltages do vary how they toggle. One goes high, one goes low. But for now, what we're just trying to show you is it has, again, bus communication. So there is no, hold on, this light's bugging me. There we go. Now I'm better. But this kind of shows you that, that would mean that, again, CAN bus high, CAN bus low, okay, but it's straight shot. There's no gateway here. So it's a straight shot on a 6-lane. So you're straight talking to the PCM, but you will see another 2 wires right here that go and talk to the FICM right here. So therefore, that's a separate network between the PCM and the FICM. That's how the computer is able to communicate the high-speed action that it wants the FICM to do to actually run the injectors. So pretty impressive, actually, if you ask me. So again, understand that it could vary. So that same truck has CAN and it has SEP for 0304, and that's what you're going to see there. So obviously you need to know those pins like I mentioned already, and those pins are important to understand. Again, 16 pins. Pin 16 is power, pin 4 and 5 is ground. So you should check for any damage to the pins. Always do that, because if you got that kind of customer that likes to play with his tuner where he's uploading, downloading, changing the tunes, and all that plug and play into that DLC is going to hurt it. So therefore, always check for damaged pins. Always can't say that enough right here. Always check for that. And there have been many cases where I haven't been able to communicate to a truck, all because the pins are pushed in. So let's not forget that obvious. And you should keep in mind that you need to ensure your cable on your scan tool has been pinched. Lord knows I fixed a few in my lifetime where the cable had been pinched enough after somebody slammed the door in it, pinched the wires in it, so the cable was the problem. But if you have Wi-Fi or Bluetooth enabled scan tool, that's even better. Now, in the early presentations I've been doing in the past, we were talking about CAN communication. So here you can see the Diagnostic Link Connector. For those of you who have never seen this presentation, I've done it before, but we're going to show you a few things here. Here's your data link connector right there, right? Okay, so there's my 14 and there's my 6 for CAN, and then we would show where A and B would go. But excuse me, but what we have here is your intermediate or low speed CAN, but it used to be single wire. Now we see what? 2 wires. So therefore, on this Ford 2011 truck, we see that pin 1 and 9 is intermittent or intermediate communication CAN. But then we got our medium speed communication, which is 3 and what? 3 and 11. So in essence, what we have is how many different 3 over here. So therefore, again, capable of, again, communicating in, again, the same languages, but in separate networks. So always remember, high-speed CAN is always on pin what? High-speed CAN is always on what? On 14 and 6. Okay, so therefore, that's what you're all looking. But that's for powertrain. Okay, always remember that. It's powertrain. Okay, these can serve other subsystems in the vehicle that are not affiliated with powertrain. You're going to see this with that. Now, I'm going to change back and go back to my service manual. We left off on the service manual with the U code, right? So what I'm going to do is, first of all, I need to get out of here. I got a whole bunch of buttons in front of me, so I'm trying to fix this. Anyways, what I'm going to do is, yes, I am an Identifix fan, for those of you that don't know. And the reason why I like Identifix is because it actually goes to, if you've seen a lot of case surveys and also stories of people talking about their issues, you're going to find that we see a lot of errors in a lot of aftermarket wiring diagrams. So especially when you're finding connectors. So I love OE service information. It's legit. It's the best stuff out there, and that's the stuff to use in my opinion. So it's up to you. But anyways, what I want to do is this. This is we want the wiring diagram. So what I'm going to do here as I do my research is, let me close this out. I want the wiring manual. There it is. And you'll see there's engine control 6.7, right? And then you're going to see module communications network. So as I look at the module communications network right here, right, we're going to see the newest stuff. Now, this is a 19 truck, and I copy and pasted it already, but I want to show you live what I'm looking at here. There is your diagnostic link connector. Well, no, this is your gateway module. Okay. So therefore, what we're looking at here is our gateway module. So as we look at the gateway module, we will also see the data link connector here within it. I guess I should say that. Sorry. But anyways, there's 6, 14, 3, and 11, right? Now there's pin 16 power. There's pin 4 and 5, your grounds, right? But look at it's all part of the gateway module. So as we continue to look at a network, you'll notice the guy that's involved directly with the data link connector, or there's usually 4 wires going between them. It first all goes to the gateway control modules. This is kind of misleading because the diagnostic link connector and the gateway module are not one. The gateway module and that 4 products right behind the radio AC controls, you got to pull all that out. There's this little module. So therefore, that's the gateway module. So the data link connector is still located at. So you'll notice again, it is all going through the gateway. So all managed by gateway control module. So obviously, if I follow the links here, and that's why I like the factory manuals, you'll notice Ford does a good job of actually linking us on where this continues. So there's my A and B. I just came from the diagnostic link connector / gateway module, and you'll notice this is where the fun starts. All of this is interconnected, right? Sync module, generic module, right? Then you got your, again, your diesel applications right there with the transmission control module, right? And it goes on and on over to the other side. Battery energy control module, body control module, and your PCM. Wow. So in this case, to get to the PCM, how many modules were involved? I mean, do you see all that? The reason why I'm telling you this, because the truck that I'm still ticked off about that there's one truck I couldn't fix last year, and I still hold a grudge against it because I could not get it figured out. I had to go. And in this case, what it was is no communication to the PCM, and you had a lot of networks that were down. And I thought I was pretty prepared for it, and I was not. So therefore, the wiring diagram, you had to split off on where the network is. So let's say we got no communication to the ECM or PCM, right? So, it'd be nice to first talk to the transmission control module, right? Are we talking to the transmission control module? So if that's talking, then we know, okay, that's okay. So you're going to try to put the link together of who can inhibit or not cause communication. Now, don't do this. Like I mentioned before, if you haven't even checked power to the PCM, because if the PCM is dead on power, fuse blown, relay open, whatever, you're going to be wasting your time. So don't forget about that. 2 is in your visual, always make sure you look for the obvious. In other words, there's some people, like the joke I always make out here is I got some people that drive their 4Runners or Jeeps and even their 4x4 trucks that don't quite understand that a truck or a vehicle is not a boat. In other words, you're looking for flood signs or any corrosion. Okay. So obviously take a look at that too as well. I was talking to an instructor earlier this week, and he was telling me, yeah, one of the things you got to look for is, what's the condition of the connectors, right? But you're trying to isolate where your issue is at. Okay. But let's not even get too far. All I'm just trying to show you is how the gateway module is now heavily used on a lot of different manufacturers. So therefore, Ford is one of the leading runs with a gateway control module, as you can see right here. All right. So again, just trying to open your eyes and try to show you. And in case you want to notice that all these links, all these highlighted links that you see there, these all will lead you to display a connector, which is going to hog up a lot of memory because I'm trying to transmit and also receive here. So let's just take our word for it. But yeah, definitely take a look at those Ford manuals to get an understanding of how they're working. So as we were showing you, right, this is early style, and then you saw the later style for 2019. So we followed the network on this is a 2011 right here, 2013. And you'll notice, again, this J and K is the continuation of it. And then we see the separate network right here on the far right here. So this is another network within, again, the computer itself. So therefore, here's the computer, right? And that PCM has a separate network here, which is, again, the NOx sensors themselves. So there you see me hit you hard and heavy about the NOx sensors. Okay. So the bottom line in diagnosing is, okay, if I have a shorted wire and it's shorted to ground, so let's say that wire is shorted here, right there. There's your short to ground. You just lost the leg of communication. Okay, and that affects everybody that's on that wire, which is that white wire circuit VDB05, right? So that means I go backtrack, it affects everything from there. So again, that's why we start off by doing some continuity tests, but also some short to ground tests, which I will talk about here in a bit. Now, like I talked about on Tuesday with my drivability roundtable, I was showing off a Duramax, what is this, an LM2. I was showing off an LM2. And if you look at this LM2 here, there's my data link connector once again, right? Now, again, now we're going from Ford to GM. You'll notice they also have a gateway control module. Okay, so this whole box, dash line box is one big gateway control module. So as we look at all the different pins from pin 1 all the way to pin 13 here, you're going to see that all goes down to the diagnostic link connector. But the funny thing is, we got resistors internally here. That's how it's shown different from Ford. So let me zoom on this a little bit. You'll notice the resistors on those wires, which are 80 ohm resistors. I'm like, I thought it was 60, but no, it's 80 ohm resistors. So in this case, you see those 80 ohm resistors right there. So that means you can do a continuity check. And I'm sure the U-code service manual diagnostic is going to tell you to go between 6 and 14, 11 and 3, and so on. So you see how that has changed? And so that would mean that all the wiring or communication, which is not illustrated here, will actually have more wires going out of the gateway control module. So like I was showing also, we saw right here, there's your ECM right here. And over here is a terminating resistor over here. So we showed this earlier this week for those of you that saw this. But you'll notice there's the serial gateway module. So the serial gateway module goes south right here, and then it goes north over here and it makes another network. So we can split this network in half if we're having an issue. That makes it nice, right? I can isolate. Okay, if I got no communication, we see one side of the gateway module and the other side of the gateway. So therefore, X2 connector is going to be my best friend on the gateway module, so I can do continuity checks. So I understand I got 120 ohms right here. So therefore, if you follow this path here, you're going to notice that that should read between 14 and 15 of the X2 connector, which is over here. Once again, these guys right here, I should read 120 ohms. That's a quickie check you can actually do. Now, on the other side, let me erase this. Now on the other side, again, I got another 120 ohm resistor there, right? So therefore, from the X2 connector, cavity 4 and cavity 5, right? Those are a continuity check to check this side of the network, and it's also 120 ohms. See that? So therefore, the connectors are separate. So therefore, we're not measuring two in parallel. We're talking about two separate networks, which fortunately have two wires for each side on that X2 connector. So that's a basic check you can do. However, what I have found to be an issue is that if this wire right here is shorted to ground, let's say she's shorted, I don't know why, but let's just say it's shorted to ground, okay? That means this white wire, okay, it's a white wire, okay? That means we got definitely a short to ground. But here's the thing. When you connect a meter, so I'm going to connect my own meter right here between 14 and 6. That's supposed to be the omega symbol. And I measure between 14 and 5. It's going to show continuity. In other words, the 120 ohms. Because we're not flowing current through there. So what you need to do is do a continuity check of 14 to ground. See if you have very low. You're going to have quite a lot of resistance because it's going to actually ground through one of the modules, but it should be a high resistance. What I'm trying to tell you here is that if you have less than 3 ohms, that immediately tells me that one of these wires is grounded, and there's my issue. Now the fun game starts to find out where the actual short is at. Okay. But again, just because a wire is shorted to ground, as long as there's no open, it still has continuity to measure the 120 ohms. It's going to read 120 ohms. Try arguing that one. So there you go. Now, obviously, there are other separate networks here, as you can see here. So again, here we can see the knock sensors are all connected in what? In series with each other. But you'll notice we have what I still call, from my heyday, the splice pack, which is J3550, what is it, J392. So therefore, 391. And in this case, that kind of allows you to tap into the networks for testing purposes. So you're going to notice we have a 120 ohm resistor here, right? So in this case, We got a 120 ohm resistor here. Who else has a 120 ohm resistor? Well, the exhaust particulate matter sensor has a 120 ohm resistor. So we got 120 ohms here, and we got 120 ohms here. So if I were to measure the resistance here, it's going to measure two in parallel. Yes, this is one circuit here. In other words, we separate this way, and we separate that way, but they're interconnected, aren't they? So therefore, it kind of flows with each other. So we got 120 ohms in parallel here with another 120 ohms here. So if we were to do a resistance check, let's say up here, how much would it read? Well, it would read what? The two in parallel. So therefore you would get not 120, but 60 ohms, right? Because you take the number of branches into the valley, which is 2 goes into 120, gives us 60. And that's what you're going to read. So, I know the ECM's up here. So therefore, what I'm trying to get you to understand is, we need to understand that, hey, are we having issues with the wiring or is it components? So let me just jump into it then. What has happened now is we have had vehicles where we have intermittent startup. We got, crazy stuff, intermittent. Sometimes it starts, will start, and you get a whole slew of U codes, or it'll actually shut down one side of a circuit. So you can have, let's say, you're shorted between the knock sensors. How many codes are you going to get? You're going to get a whole bunch for knock sensor 1 and 2, and then 3, and then you got the exhaust pressure. Everybody's affected by it. So now is the time to say, okay, what could be the problem? So unlike other people teaching, I have found that more often we see component versus wiring failure. So I know we can have shorts and so on, and we could have water intrusion like flooded vehicles and so on. I get it. Or maybe it was in an accident and the wiring's damaged, but most vehicles haven't had that kind of issue. We have found those components to be the problem. So when I see that, that kind of tells me, well, we got to start disconnecting stuff, right? We got to start disconnecting knock sensors. And that, believe it or not, is becoming a common practice for those that have dealt with these issues on these trucks. Make sense? So who's managing and actively viewing these networks now? That is the gateway module. So the gateway module is not just being the distribution point of the networks, it's also monitoring too as well, and it will actually do what you need to do. So in the early years, right, we had to go ahead and do a resistance check. There's your diagnostic link connector. There you can see the BCM being the gateway. We got 120 ohms right there, right? And then we had another 120 ohms at the PCM. They were both connected in parallel. So like the meter reads, it was supposed to read 60 ohms, right? So, that was pretty easy. 60 ohms, that's one ring. Okay, no big deal, right? All right, let's keep moving on. A tool that you need to have as you're talking about networks is some type of breakout box. Okay, you need to have the breakout box. I own the one on the upper right. That one has worked very well for me. I've used it in classes. Highly recommend it. But there are other ones that have the LED lights that light up. So therefore, these are other breakout boxes for you to test the circuits. But we're going to try to make it easy as you diagnose, because again, those breakout boxes work very well. Now, as we look at, I'm going to give you a few images from different people that we've gotten these images from. There's, again, we saw that pin number 6 is what? Bus high or low? Because, oh, by the way, in case you don't know, high means positive, low means what? Negative. Okay, if you haven't learned that in electricity. So therefore, when we talk about bus high, that means we start off at 2.5 volts. So first, let me get started. We do start off at 2.5 volts right there. So that middle line is 2.5. So a quick test you can do between 6 to ground and 14 to ground on these trucks is you're going to tell me if you have what? 2.5 volts. It starts off at 2.5 volts. If you have 0 volts or 12 volts or anything else, game's over. You need to figure out why you don't. We're going to start looking at that. But the base voltage you should see as you turn the key on, again, key on, and you're going to measure that is you should see 2.5 volts with a meter. Unfortunately, since we have high speed, in other words, we have pretty fast modules communicating at a fast rate, on and off signals, right? That means that, the meter can only read the average voltage. And the average is, again, the 2.5 that I like to reference there. Now, bus low toggles to what? To 1.5. So it starts off at 2.5 and then it jumps down to 1.5. It never goes to 0 while communicating. Obviously, if it's at 0, it's because everything's asleep. But again, we're toggling down to 0. And this is important to understand because you can actually start connecting the scope. I know a lot of you have scantles, which have built-in scopes, or you have a scope. It's time to play with it, right? So in this case, you're looking for that base voltage on a meter. You can use a meter, and you can see if you have 2.5 volts, but then you want to see it if it climbs up to 3.5. And when you tap into 14, does it also drop to 1.5? We're going to show you this in a minute. So just see it in a different light. Again, 2.5 is our starting point, and we climb up to what? 3.5. That's your can high, and then your can low drops down to what? 1.5. So if I were to separate them, which I will here in a second, you're going to notice that one goes from 0 to 3.5, and the other one goes from 2.5 to 1.5. That is CAN communication. So imagine now, let me backtrack now. Let's go back to our wiring diagrams. If I'm leaving at this wire, what should I have here? Well, if one's CAN positive, one's CAN negative, right? So therefore, there's these two wires right here. And in this case, one's going to read again. I could put my scope there to see if it's talking. And you could do that simple trick, go back, probe a connector. And what you can do is 2.5. And then after verifying 2.5, tap into each one individually and see if one is going high to 3.5 and the other one's going down to 1.5. There you go. So in this case, basic checks that you can do. That's why the scope is going to become your best friend. Why? Because your meter is only going to read the average voltage of 2.5. So the meter is not a useful tool. Well, it's okay tool when it comes to CAN to read the 2.5, but then afterwards you got to see if it's toggling high or low. Because if you have a grounded circuit, it could default to 2.5, on the other side. But no, there is low speed CAN, and low speed CAN toggles between 0 and 5, right? There's your low speed. Remember that pin number 1? So in this case, it toggles high to 12 volts to change messages. But then as it's chatting down the road here, it actually is going from 0 to 5 volts. So that one does go to 0, right? Unlike the 2.5 that we saw with CAN. So low speed CAN goes from 0 to 5 volts. But as you notice right here, it has a variable pulse width. Look at the lines right here. Look how short this one is and how long this one is and how short this can go. So in other words, it varies the pulse width, so it can vary messages much more effectively. So that's pin number 1, right? So when you connect to view, let's say you don't have a breakout box, it's as simple as going to 6 and 14 right there. There you can see that I grounded my scope. I don't show that, but my scope is grounded and I'm tapped into 6 and 14. And that's how easy it is. Obviously, I use my small probe leads to actually not hurt the terminals and not spread the female terminal. It works very well. And in this case, I'm going to see that I'm going between 6 and 14, and I'm going to be able to see the scope. So that's how easy it is. For those of you that never physically done it, again, you're going to get creative. So as I've shown before, you're going to notice here that, let me change this cursor here. Hello, and get rid of this pin. And now I can play it. So what you're going to see right here is the high-speed CAN in action. I don't know how fast it's showing it on your screen because it is moving quite fast there. All right, let me pause it. So there we could see my scan tool, which is my scope, which is on my Snap-on Zeus. You're going to notice that it's actually going up to what? Roughly what? 2.5 right there. So if I look closer, hopefully you can see my cursor, there's 2.5. And then you can see it climb up to roughly what? 3.5, because you'll notice 4 is right there. So there's climbing. Now on the low side, what do we see? Again, we see 2.5 right here. Look at the different colors. So we're looking here. And you can see 2.5, but then it drops down to roughly what? 1.5 right there. So that's classic CAN, right? So all I did was, again, connect my dual channel scope, have it 2 separate setups, but I can see how one climbs up and how one climbs down. So this is CAN as you see it there. So again, now don't try to decipher what the hell is. Nobody does, because you're only getting a fraction of it. You're not seeing the whole picture, but it kind of shows you how communication is taking place there. Pretty cool, right? Pretty cool. Okay, all right. So hopefully you're still awake watching. But anyways, there's your CAN high, CAN low. So that's what you're going to see there as you tap it into those circuits. Definitely works for you. So I guess what we're trying to show here, who's going to be your best friend to actually tell you how well that CAN network is communicating, your scope, okay, your lab scope there. So, because again, the meter can only read the 2.5. So as we talk about the speeds, right, there's low speed, that works at 33.3 kilovolts, which is 33,000 bits per second. Now, the reason why I actually put this early slide here is just to show you how communication is shown. Back in 1998, we were at what? 10.4 kilobits per second. Now we're at 33 on the low speed side, which by the way, now is, I haven't got the latest figures now, but it's faster now. But in this case, talking about 10.4 to 33.3, that's quite a lot of change. But then you got the speed, the medium speed, which we saw earlier on a Ford product, that is 95.2 kilobits per second. But all of medium speed is two-wire communication. So now you're really moving some serious data. And then we got our high-speed data. And that high-speed data that we see on pin 6 and 14 is 500,000 bits per second. Now, these numbers are old, so I'm sure that has sped up because the difference between an old module and a newer module is its speed, right? Memory too, but speed is the biggest thing. So it is moving quite a lot of data at a given time. I mean, we've got a common rail injection system that can fire off an injection between 4 to 7 times for a combustion event, guys. What kind of high-speed stuff is that? I mean, that's some serious speed that's going on there. Now, when we look at a RAM application, we saw GM, we saw Ford. What about RAM? Well, we've shown this before with RAM, but you're going to notice there. First of all, I'm going to lay it out, then I'll zoom in on it. But you're going to notice right here, Diagnostic Link Connector right there. And that diagnostic has those two wires here going to, again, this big box right here. So this big box, right, is what? Is a star connector, right? So in this case, that is your star connector. So that is the guy that interconnects all these modules. You know, this guy, I mean, all of everybody. I mean, you're going to notice they all talk together, all on that same, what? Star connector. So therefore, that star connector is pretty critical because we're seeing aftermarket devices now that can tap into the star connector and actually do programming or add other aftermarket components. That's a nice thing about the star connector. And the guys have figured that out. So I guess what I'm trying to say is CAN bus is used in various different components, right? So here we could see two wires coming down here, and this talks to another star connector, which is star connector C here. So therefore we see this one here, C, and we see C over here. Again, this one is on it says dash. This one's in the instrument panel cluster, it says right there. So in case we got another module, and over here we can see our powertrain control module there. So that means from the DLC all the way to the ECM, you had to go through that. But how many modules were involved in this whole thing? It's all these guys, right? So therefore, that's how RAM sets theirs up for you to understand. So this is all in their wiring diagrams, but let me zoom in a little bit. So as I zoom in again, there's my diagnostic link connector. There's my pin 16 of power, and there's my 4 and 5s of ground. So that's a consistency. It's all the same. So in this case, we see pin 6 and 14 right there going up to the pin, all the different modules. So body control module, their trailer module, and so on. Then you got the ones on the top, which is again your park assist, your radio, your module, occupant restrictor controller, and your interface, not to mention your cluster and your steering module control or steering control module. Holy crap, a lot of them. So therefore a lot going on here, guys. But like I said, we got a lot of communication taking place on this star connector. Okay. Make sense? All right, hopefully you're learning here on how these are designed. So what you're going to see now, for example, I got this from Amazon. There's now security gateway module harness bypass cable accessories that are now being sold. So I guess this works for the Cummins Ram pickup for 18 and 21. So as you can see here, it works with other aftermarket, like you can even tap in a remote start, right? So therefore, you're no longer adding, shall we say, a switch per se. You're adding a module into the network to communicate and perform certain tasks. And you know what other companies are using them? You know, amp steps and other aftermarket. I'm not even going to name them all because what it is, it allows to tap into those circuits and be able to program aftermarket accessories. But again, they're tapping into the CAN network. Okay, that's what you're looking at. So how are they doing that? Through the star connector. So if you see on YouTube, there's a whole bunch of videos talking about that and how they're going behind it. Some are, you know, just pop out the headlamp switch. You could tap into the, again, the star connector there. So I guess what I'm trying to say is it'd be a good idea as you deal with these issues with these trucks that could arise to start knowing where these star connectors and splice packs are looking at. So like they're saying there, the Cummins bypass cable, also known as security gateway module, is used for a variety of purposes, including flashing the tune, changing different settings, adapting aftermarket remote start, and again, it works with different scan tools. Also, the cable attaches the OBD2 port and the SGN adapter plugs directly into the start connector and port underneath the dash. The start connector can be found on the far left underneath the dash next to the door frame. Again, don't try to memorize that because there's videos out there that show you where they're located at. Hey, I've used them. So therefore it works. So if you haven't caught on to what I've been talking about is, what are you talking about? Well, here's your whole network for Ram Cummins right there. And what is this guy here? This is your star connector. So therefore this whole box is your star connector. So you can tap into that star connector and again do modifications or installs, but it's not something you're putting power and ground to. No, you're tapping into a network so it communicates now. In other words, you're adding another module in there. So, but not only is it a place for diagnostic purposes where you can try to isolate who might be your problem, in other words, start separating networks, but it's also your place where you what? It's where you can actually communicate everything to the diagnostic link connector. But I got to tell you something. Let's not don't overanalyze it because as I look at the diagnostic link connector one more time, right? And I'm looking at that 6 and 14 right there. I'm going to connect my scope there and see if we're talking. I already got the presets done on the scope. I did my homework. It's just you saw how I connected the leads, bang. But if I have a breakout box, that's even better because I can actually measure my battery powers and grounds and so on. So again, don't forget that battery power thing of the basics and make sure everything's nicely plugged and no corroded connections there. So what do you think? Pretty cool? So therefore, yeah, that's what we're going to see now in the aftermarket. So very important. So like they're saying there, I even got this from another one. There is no need to backpin or splice on the OBD2 connector. Remove the radar to diagnose, monitor, update your truck. So their links is on also another component out there to taps. So, there's aftermarket stuff to help you, again, update that truck or program that truck. Obviously, we don't encourage deletes. We're not talking about that. I know some of you do it, but that's a different story. But again, we're just telling you that's a way of tapping into those circuits. And you're going to find other makes and models are going to get similar setups where now they're figuring out how to tap into these circuits. I mean, we got now entities out there, if you're not aware, that have learned how to, like, for example, I just recently saw Duramax put into a what car was it? I think it was a Dodge Challenger. I think it was. I forgot. But they got little boxes now that translate the CAN communication from GM to Ram, or not Ram, excuse me, to Dodge and Stellantis, and it all talks to each other without having to modify anything. In other words, CAN is CAN. So they figured out how to get them to talk to each other. So you're going to see a lot of nifty stuff, pretty cool stuff out there when it comes to the CAN communication there. So let's go back to that knock sensor now. So hopefully you have seen now that power and ground are very important, but this is where the voltage drop test comes in, right? Before you can start, having issues, with communication and you've isolated to a module, let's say, it always means you're supposed to check power and ground, right? So got to check that power and ground. So in this case, if you don't check that power and ground, that module could be acting loopy if there's a high voltage drop. I cannot stress that enough. So as these vehicles are going to age or they're exposed to the elements, but then again, like I criticize with Jim, I'm sorry Jim, I love you, but I'm criticizing you, your connectors suck. We've had connector issues, right? So in this case, you definitely want to pay attention to the quality of the connector, make sure we don't have a high resistance fault, thus causing a high voltage drop. So that's why those pins you saw earlier, I use those a lot. I even have the whole back probe kit that I've shown in my classes. And in this case, what I'm trying to say is note that you got to probe carefully. You don't want to break the insulation, so know how to back probe correctly as you're measuring the source voltage and ground. In other words, doing a voltage drop test here. So can't stress that enough there. Okay, so obviously you're going to need to actually you're going to actually need to what's the word I'm saying, in other words, pull up the wiring diagram. I mean, we saw the differences. We just saw Ford, we saw Cummins, Ram Cummins, and we saw also GM, and everybody's doing it their way, right? So when now you have a gateway module involved, what's happened to the star connector? What's happened to the splice? Well, it's still there, but it's only in certain networks. Let's observe it. And I didn't point that out. My apologies. Because what I'm trying to say is that you got to know how the network is set up. The only way you're going to know is to actually what? Go ahead and pull up the wiring diagram like I've been showing you. So again, there's the Ram Cummins application right there. Totally different because as of yet, I haven't looked at a 22 truck, so don't quote me, but as of right now, not 22, I know that Ram has not gone to gateway, but GM and Ford have gone to a gateway module. So, oh, I know what you're going to say. The earlier Ram trucks did have the power distribution box, aka known as the TIPM. That was their gateway. You're right, but in this case, not so here. So you know because it's not a gateway because yeah, you're interconnected to start connector. If you notice how the wiring is, it's just a connection point. So yeah, we got some questions here. What was the question here? They're plopping up in here. The rotunda, I'm not talking about the OBD2 breakup box. Yeah, that's one of them that you can tap into the circuit, Matthew. Yeah. Do they have a universal gateway module? No, not that I know of. No, I haven't seen that yet because I've been doing a lot of research on this and no, I have not seen it. If you do, let me know, but not that I know of. So yeah, there you go, Matthew. Good questions there, my friend. But anyways, yeah, you're trying to isolate. But I got to tell you that breakout box, that second breakout box, I have seen it and I started looking at it closely. I go, knowing the problems that we have with networks, I said, well, the problem is, you're trying to isolate. That does not help me isolate circuit. It helps me tap into circuits, but it doesn't help me isolate. The name of the game here is isolate. Like I said already, let me erase this here. And that's something I need you to take home with you is the fact that what if the component itself is doing the ground? He's shutting down one leg, let's say, right? Let's say he's got a short to ground internally in this module. How many modules does that affect? Well, it affects everybody. That's the point. Now, what word to the wise? Let's say there's a start connector here on the dash, and this is the start connector here on the instrument panel cluster, right? And I can't talk to the PCM. What we can do here, let me tell you a Tony trick is, you're going to have to cut and splice though. But what I will do is I will bypass the data link connector all the way over to the PCM. But before I do that, here's what I do is I know that the connection between the two star connectors is right here, right? If I disconnect these connectors right here, if I'm able to disconnect connector, you're going to notice that I can get on, this is connector 4. This is connector 1. I don't know if you can barely see it, but that's connector 1 and this is connector 4, right? I can go ahead and tap in with my scope on these two wires right here, and I should see can high and can low, because even though it's disconnected, this module from the network, is it still spitting out 2.5 to 3.5 and 2.5 to 1.5? The answer is yes, he is. So therefore, that tells me, okay, he's talking. But over here at the diagnostic link connector, I can't talk to it. So therefore, there's something wrong between point X and point Y on this start connector because I disabled it right here at this connector 1. Makes sense? But I'll just tap in here directly. That's where you can connect your scopes. That's why I don't see me buying any of those tools, unless you're trying to program the one I just showed you, Matthew, because of the fact that I could use my scope to tell me what's going on. But let's be fair. What's the issue here? Time. Is it labor intensive? Yeah, because as much as I see it beautifully here on a wiring diagram, this module's over here behind the dash. This is over here. So you got dashes apart, you got panels off, you got this off. Yeah, it's going to be a little bit cumbersome to try to isolate where the problem is. So that's why, you want to start your diagnostics, as I started this presentation, about checking, your powers, your grounds, and also, again, verifying connectors, clean connectors, right? So anything I can get a connector on, let's double check to see if there's any evidence of moisture, anything going on that could be the cause of problem, which we have fixed in the past, okay? So don't think it doesn't happen. It does happen, so be aware of that, okay? All right, so the scope is going to be your best friend. Let me erase this and let me move it forward because it won't let me move forward unless I do this. Hello, there you go. Erase all the ink and let's take it back to my cursor there. All right, and again, please feel free to ask questions as we move along here. I think I'm just about done here. But in this case, again, just note that aftermarket stuff that's out there to diagnose you and help you issues. So like I was showing you earlier, The service manual does a pretty good job. And don't forget about the diagnostic trouble codes. Oh, that's where I was going to. Yeah, let me go back to the Ford real quickly here. Now, as we look at the Ford here, we saw the wiring diagram here, right? But in this case, when I look at Ford and I go up here to my, this is my wiring diagram. And for those of you who don't know, PCED is the Powertrain Control Emission Diagnostic Manual. So as I go into the PCED, I like to go ahead and go to my diagnostic subroutines, and it should pop up my diagnostic trouble codes, right? There's my diagnostic trouble code list. They put it this is Ford service, so don't blame the messenger here, okay? So as I scroll down here, I'm going to go down to my U codes because U codes are towards the bottom. So obviously, if I do have a communication problem, it is very likely you're going to have, I'd be surprised if you didn't have one, but it could happen. One thing I've learned about this trade is Murphy's Law. What can happen will happen. Anyways, I'm trying to get to my U codes here at the bottom. There's my U codes here. Okay. First of all, take a look at the U codes that are available to you here. Let me scroll up a little bit here to get to the first one. And there's quite a bit. Okay. We do have quite a bit of U codes where you can have communication. If you don't believe me, if you ever dealt with a low battery situation, everybody sets a code for low battery, right? So they're all interconnecting, they're all getting the battery power. Okay, that's the end of my P codes. And here we could see our high-speed CAN communication bus performance. So that's U00002, then you got 73, your control module communication bus off, communication bus A off, right? B, and then you can see ECM, PCM A error. So again, you got quite a bit of codes available to you, right? So transfer case control module, lost communication with glow plug control module, right? And even your fuel pump control module, because we all know we use a three-phase pump on these applications, right? So again, the list goes on and on of what's available for you. So when you put on that scan tool and you see that U code and you don't want to deal with it, sometimes you may have to deal with if stuff ain't working or if you have intermittent concerns like stalling. Yes, a stalling issue on a truck, it can be attributed to a network issue. So therefore want to get to know this stuff, right? U codes could be your friend. Anyways, so as I'm looking at this, let's see, let's go to glow plug control module. So as I global, it takes me to test point, pinpoint AE. If you've been following forward, there's your connectors for your map sensor and other related sensors. Again, we got a self-test network communication error introduction, right? So it introduces that. And then you go ahead and follow the test. Now, one thing that's nice about these Ford products is that they do run a network test, okay? For those of you that ever used IDS, nobody looks at IDS while it's creating the session. Nobody looks at the bottom because on the bottom, guess what it's doing? It'll clearly say as you're logged in IDS, it'll say network test, right? You can run network tests and also aftermarket scan tools, not all, but a lot of them. So in this case, what you're doing is you're communicating to all the modules. So like it says right there, when using IDS, a scan tool attempts to communicate with the PCM first. After establishing communication with the PCM, the scan tool then attempts to communicate with all modules on the system, aka the network test, right? So, is there anything that has passed or failed, right? So it's done. If you have these codes, go to the perspective charts. So you can run an on-demand network test to start the thing going in case you have an issue. But here's the beauty. That's why I talk about forward with self-test is you can run it again and again and again and again to see if you get that intermittent problem, right? That can happen there too. So anyways, let me just follow any code. Let's say the U106. It says there, it starts off by saying check for glow plug control module concern. Is there any concern present? You go to the chart, check for analog. So what it's doing is that it's trying to isolate which modules are working and which modules are not. That's what it's trying to do. You follow? So I guess what I'm trying to say is don't underestimate the power of the the U codes of how it can help you there. So obviously I could spend days talking about this with like I do in classes, and I'll be doing more and more of my presentations online. But in this case, give the service manual a chance, follow the steps on how it wants you to diagnose and understand what's capable of doing, what it's not capable of doing. Very important to understand that. So, all right. Let's see, go back to my slideshow here. So yeah, I'm just about, we're almost coming up close to it. And we got another question here. I just got it popped up here. What's Matt says, are there currently any dummy knock sensors, test resistors, for example? No, you see, that's the point, Matthew. Matthew, you fell into the trap. You see, the knock sensor module speaks CAN. So if I put power and ground to it, it talks CAN. So in this case, it has that language it has to speak. So no, there would have to be a CAN module for it to work that speaks the identification modifier, the identifier that tells him, hey, because he has to introduce himself in the network saying, hey, I'm Mr. Knox sensor. Mr. PCM says I'm Mr. PCM. So therefore, no, there can't be a dummy. Nope. So therefore, because they speak different languages. So even though it's CAN, the identifiers are different. So no, you can't do that. I guess the only answer I could give you is you probably want to keep a spare knock sensor, but no. But again, for you and me, your best tool is the scope, like I showed you. So therefore, you can see your CAN high, your low. You'll see that on the wiring diagram, and you'll be able to actually see those two signals to how well they're communicating. Hopefully that's kind of doing that for you. So yeah, you kind of answered the question there at the end of having a good known sensor, but that again, you can use the scope. What are we supposed to have once again? 2.5, right? And guys, in case you don't understand, let me backtrack. All right. Where did that whistle come from? On one communication wire is high, the other communication is low, right? So on the high, it goes from 2.5 to 3.5. On the low, it goes from 2.5 to 1.5. So I'm connected to one wire of that knock sensor. That's one communication. Let's say I'm on low. I'm on low. I identify it on the wiring diagram, and I go from there to ground. What should I read on my meter? 2.5. Now I go to the high CAN reading on the knock sensor, and I go from CAN high to ground. What should it read? 2.5, 2 on the meter. Now, then I could see now, connect the scope, and I could see if it's toggling on the high side from 2.5 to what? 3.5, and on the low side from 2.5 to 1.5. Two separate circuits that talk. So that's your best friend. So I guess what I'm trying to say is you saw Tony hook up the scope, you saw the image, you can start doing the same to see if it talks. Definitely want to do that. Now, I got to tell you, this is how I came up with it. When we had that Ram Cummins that had the shorted knock sensor that was shutting down that side of the network, what I did was I said, this puppy should talk CAN. So therefore, what I did was I checked to see with power applied to the knock sensor. Mind you, I got creative with pins, and I put power and ground to the knock sensor. You know what? You just gave me an idea, Matt. I'm going to get a knock sensor. I'm going to lay it on the bench. I'm going to put power and ground to it. I'm going to identify which is pin. And what should I see at the other two pins? It should be talking, right? So we should see the 1.5 to 2.5. So we can bench test the knock sensor provided we put power and ground to it. You got me. You know what? You just gave me an idea, man. I'm going to be doing that. There you go. All righty. Very good. Hopefully you're understanding that. I know it's a lot to suck in, and I know, get it. I understand that, but yeah. Yeah, I'm just about done there. Mr. David, are you there?
I am here. That was a very, very
Yep.
good, informative presentation, Tony, as usual. A lot of information there. And speaking of a lot of information, can you elaborate a little bit maybe on some of your classes? If somebody says, yep, I understand quite a bit of this, but I really need more training. Give us an
Well,
idea as to what you
here's the
offer.
deal. Yeah, here's the deal. Obviously I have on-site classes. Like next week, I'm in Denver over at Lion Park teaching classes. I'm teaching classes everywhere. But I get a lot of complaints in shops for some because if you talk to many trainers lately, everybody's slow. Okay, everybody's slow. I've been calling other guys that I know in training and instructors is slow. So the excuse I get is we're too busy, we're too short-handed, I can't afford blah blah. I said, okay. So what we have done now on my website is I have put on Powertrain Training, you can request a login. Matthew's on board on it. And Matthew, if you want to give your 2 cents worth, you can tell me what you think of it so far. And you can tell the truth, is that I have put the Diesel Master course online. Okay. So this is using the talent management system where these guys can watch the video, then take a test, and then, keep going. So I guess what I'm trying to say is we are going more online due to the fact of the demand. And summer's coming. And for us trainers, summer's usually slow when it comes to face-to-face classroom training. So in this case, online should supplement that, and I hope it does. So therefore, on Powertrain Training, thank you for mentioning that. We do have the on-demand courses. If you just want to watch a previous recorded class or a class I recorded, or you can actually want to come on board on the online these Talent LMS, which is the learning management system, where we're going to watch your progress, you're going to take tests, quiz, and to me, that's going to be actually something that kind of acknowledges that you do have competence and understanding of it. Because, as I mentioned at the beginning, some guys don't have structure or understanding what they're working on. You should see the phone calls I get. Some of them are good, but some of them are driving me crazy. But yeah, online courses are available at Powertrain Training, so please be fair there. So
Very
cool. So
good.
Matthew said, yeah, he's good so far. Matthew likes it. See, there you go. Matthew made a mention there. So there you go, sir. Yeah, we do have online classes, guys. And oh, and one more thing. I just came back from Washington about less than a few weeks ago, and I also do on-site trainings. So if you're a shop and you want to hire me to teach class for 2 days, 3 days, whatever, we're flexible. We do that too. That's my favorite kind of training to do now, by the way, because I got you in the shop. We're going to diagnose trucks, and they were enlightened. They were very pleased. So I've been getting good feedback on all that stuff when on those on-site. So if you want on-site training, there's my phone number down there. Give me a call, or you can email me. My email link's in the website too, so you can send a message. But thank
Very
you,
good.
David.
Appreciate it. The next question that's on here is somebody wants to know when the next webinar is. And the next webinar is going to be May 21st. Same place, same time. So write that down on your calendars, May 21st, and we'll be sending out reminders, in the very near future. Another question that was on here in the chat was, where can I buy injectors from in Minnesota? And the answer to that question there is Erica, that you can see her name here on the screen. Erica will be contacting you, so she will be able to give you all the information that you need. And I think basically, Tony, you've answered all the other questions as you've been moving along, which is relevant to the subject matter as you were moving. And I really don't have any more questions really for you at this very present time. And I just want to thank you, and I want to thank the audience. Thank you very much for joining us today. As always, we very much appreciate that. And as Tony always says, hope you learned something. And we look forward to seeing you again on May 21st. So hope you have a great
Yes.
rest of the day. Thank you and goodbye.
Thank you.
Goodbye, Tony.
Goodbye, Mr. David. Goodbye, everybody.